right, welcome to AI FISEC today, where we're embarking on a thrilling journey into the intersection of artificial intelligence and the physical security industry. Today, we have Chrissy McCutcheon, who is a principal and senior consultant at Security by Design. Super excited to have Chrissy on the call. I know we have been talking together about getting you on for a bit, and couldn't be more thrilled to have you, Chrissy. Welcome.
Thank you. Great to be on.
So, in normal fashion, we like to start by having you as a guest tell us about your background, your business, just so the audience can get to know you a little bit better.
Sure. So I've been in security for about 20 years now. Started by being appointed as a security manager in the command post at Baylor Force Base. And then that expanded to covering the headquarters too, and eventually transitioned into becoming a government contractor. I was a security analyst overseeing the physical, industrial personnel, and information security programs for 9 different squadrons around the world. And then about 10 years ago, I moved to Security by Design as a security consultant. And our focus there is global design standards. So we primarily do multi site, multinational corporations. And I'm becoming a key owner's rep for designs, construction support, and implementation. So we do all sorts of different projects at different levels, different industries. But it's really being that owner's rep where the owner doesn't even necessarily need to be part of the meetings because I understand how to implement the designs that they want for a very cohesive security system.
Awesome. That sounds super intense, but also really exciting at the same time. Awesome. So tell us, Chrissy, something fun about you. One fun fact.
One fun fact: I wanted to be a computer artist when I was 5. So that was my dream job, not fireman or police officer. But I've always loved art and photography, and it's really interesting right now. All of the options, improvements in data processing, and everything's improved so much now that it's easy to take a picture like the one in my background here that I took on a plane ride on a business trip and then turn it into art. So it's being able to visualize something differently than how everybody else sees it. And now the tools are so much easier now to just make that happen in 5-10 minutes to make your creations come to life.
That's awesome. I was actually going to ask if you did your background and you answered it for me. So good job. Good job. It looks nice.
Thank
So
you.
on that note, because I know this isn't the podcast title, but I also like to dabble in art too. But one of the interesting things about the art industry around artificial intelligence or generative AI is, I don't know if you know, but it was either they won an art contest or were a finalist in an art contest for a artist that made art using Midjourney, just by prompts, and there was a conflict on whether or not that is considered art. But from the way they were able to get approved to be a finalist or they won the contest was because that the judges saw the prompts in the specificity that was listed in the prompts, the amount of creativity that was in the prompts, and therefore it was art. So super interesting to see where art will be in respect to
Definitely, yeah. When you
years to come.
see how they can take a photo of a desert and turn it into an ocean scene with just a few prompts, it's really amazing.
This was made with Midjourney, actually. So
Oh, really?
yeah,
Very nice.
yeah. All right, so now let's get to the topic at hand. The topic is Wayne AI Edge pros and cons. Man, I have been thinking about this for a while, even when we met at GSX months ago. It's something that I still kind of figure. I think that a lot of people are talking about and trying to figure out, especially manufacturers as they make new things, right? Like how much should I bring to the edge, take away, where's the middle ground, right? So, yeah, kick us off. Tell us what you think.
I mean, I think it's important to kind of start with the what is the edge, right? Like, what is that definition? So the one of the official definitions is it allows computations to be done close to where the data is actually collected rather than at a centralized cloud computing facility or an offsite data center. So it lets the devices make smarter decisions faster without connecting to the cloud or any sort of offsite thing. You don't need an internet connection to be able to do the computing at the edge. And because of that, it allows benefits related to infrastructure costs, scalability, high utilization, resilience from server failures, and it offers the faster response times, lower bandwidth, and resilience from any network failures. And when we were talking in GSX, we talked about the fact that edge can kind of mean two different things because when it says it's being done close to where the data is collected, that could mean that it's actually on the sensor, whether that's a camera or some other sensor device at the edge physically, or on site close to that device if you need a little bit more. But it's prior to it going off site to a data center or to a more centralized server.
So maybe walk some of the audience, right? Because sometimes we might have people that are from the industry, which I'm sure primarily, and then others that might not that listen in. So what would be maybe an example that maybe like a camera topology that we could kind of walk through on those differences, those nuances, and like an NVR, maybe have maybe a IP camera on the edge versus having a IP camera on the edge straight to cloud or in a virtualized environment or something, or what's your impressions on it?
Yeah, so you have, if we take the cameras for example, so they now have way more onboard storage and computing capability, and they can do their inferencing all the way at the edge. And so they can take not just the video, but create the metadata and inferences of, that's a red shirt, or that's a vehicle, or a person, or very basic concepts, and then send that as data instead of video, and um, and then that information doesn't need to be on the NVR or server to be able to do review the video and try to figure those things out. It's all happening on the camera. Then you have the NVR level where it's getting all of the full data from the cameras and then analyzing it to figure out those things. And then you have the other ones where it goes to the NVR and then gets processed somewhere else. Sometimes that's another server on site. If you have, are we supposed to say companies? Like like a brief camera or something that has their own server because they run way more processing on that, and so it's an on-site server that does a lot more um, analyzing of that data from every camera source. And then you have the ones where it's just fully done in the cloud, and it takes every bit of information from all of the different sensors and processes it all in the cloud, which is super scalable. But you have a lot of bandwidth requirement there for it to do all of the analyzing and not just collecting the metadata and deciding, yes, this is something that's really important. We want to capture this.
Yeah. Yeah, because it's so with all those options, it's I guess a customer decides based on what, like their maybe their financial resources. Is there an advantage over one versus the other? Like is there an ideal place? I guess is a better question. Now and maybe a different one in the future that's more ideal.
So, I mean, there are definite benefits to doing stuff at the edge. So you have your real time insights
Mm-hmm.
where the camera can alert to somebody crossing a line right away,
Mm-hmm.
right? And all of that can happen all the way at the camera. And so it reduces the latency of sending the image, then it being analyzed, then producing the alert. So it can actually be faster that way. It's reduced cost. There's less power usage because you're distributing all of that computation across all of these little devices,
Mm-hmm.
uh, and then reduce bandwidth costs. You don't have to pay for as much bandwidth to, so that in general reduces costs. You get the almost instant intelligence from the cameras. They can decide whether something's important if you have it recording only on alerts, then it's not recording everything all the time. And so you can teach it what you care about. Increased privacy, so a lot of the information is being done at the sensor
Mm-hmm.
location and not getting sent until it's kind of more anonymized data.
Mm-hmm.
And then um, scalability, it's really easy to just add more and more sensors, and so you're getting the benefits instantly of those new sensors and what their capabilities are.
That's because
Um,
you have the compute spread out, right? Meaning that's
yeah,
using those resources at the edge as opposed to, hey, I'm doing a dumber device and now it's using more resources in the head end or something.
right.
Okay.
Yeah, and then and any of those things where you're doing the AI at a central location, then there's usually those costs per device.
Mm-hmm.
And then how many things do you want to look for? Where if you buy a camera that already has all of these things built in, that's baked into the initial cost of that camera versus a recurring cost.
Interesting. So what drawbacks do you see with that topology, if at all? It sounds good. It sounds like that's just the way to buy it, right? If people have money, just buy that
So
way. Yeah.
I think, one of the biggest ones is limited computing power and memory because you're still limited to what fits on that edge device.
Yeah.
And so yeah, they've been able to do amazing things on tiny little chipsets, and
Mhm.
SD cards are can hold crazy amounts of data that when we were younger was just not possible. So I think that limited computing power and memory is a huge drawback there. Typically, the computing power can do more of the lower level inferencing, so you
Mhm.
can get, like I said, yes, that's a person. Yes, that's a vehicle or an animal. The very well trained simple models, but it can't do the more complicated. Like, is this more of an anomaly? Do we not usually have you know this kind of truck driving here at this time of day? What's the
Mhm.
more complicated stuff tends to happen on the larger computing resources. So that kind of leads to the restrictions in the deep learning frameworks. So um, I think one of the big things is, the edge devices will download a model and they're using that training structure to make their inferences. And so when they're also connected to a system where they can keep getting new downloads of that model, then
Mhm.
they're learning more. But some of them are limited to what they came out of the factory with. And it's not learning, it's not growing or changing. It is what it is, and that's what you're stuck with. And so there are limitations depending on what manufacturers you go to and how their devices are structured and their learning models. Um,
Yeah.
the There's
Oh,
one more challenge of the if computing is being done in a data center, it's in a very controlled conditioned space. It's an ideal temperature.
mhm.
It has all of the power it needs. It has a very stable environment. When you're putting all of these sensors out at the edge, they might not be in ideal situations. They might
Mhm.
be too hot or too cold or inconsistent power or inconsistent network, or the conditions aren't nearly as good. And so you might lose out on data because it's trying to do so much at the edge and it can't handle it all.
I never thought about it that way. That's really interesting. That environmental considerations of putting too high of a tech on the edge, right? It's like
Yeah.
because it makes sense to say, hey, let's put all our chips in one basket and this one device on the edge. Let's say for some companies, and then okay, well, yeah, you're right. For maybe certain areas, Or if it consumes a lot of information, like if it's an outdoor camera, maybe there's activity, it's a high traffic area. That's a lot of compute on that one device. That's interesting. How I've never personally spec'd like an AI edge camera that was maybe in a very busy area, that was just edge to offsite storage somewhere,
Hmm.
right? It's usually like edge to an on-site NVR, and then NVR spec for you know um, motion, right, or whatever it's going to capture within the frame. Um,
Right.
that's interesting. I never thought about it that way. Yeah.
So I think, we kind of touched on it, but training is a huge issue for them. So, you've got your um, essentially every AI model is trained somehow, right? And so it's somebody or some group of people showing examples of what kind of data they're trying to identify or categorize, and then making sure to train it with correct answers.
Hmm.
But if a system hasn't seen something or it can't quite figure out what it is, then it needs to keep learning as you get something new. And so there are benefits to kind of doing a hybrid model where there's some stuff at the edge and the more basic, you know, human vehicle animal sort of level, and then sending other data to an engine that can do a more detailed review and get um, you know vehicle models and things like that, where that's too much for an edge device to be able to do. And then as your um, some of those more central things can go through and really identify the anomaly situations
Hmm.
where um, or uh, there are companies that can run analytics that determine if somebody did a slip and fall or climbing a fence or doing different activities. Like,
Hmm.
yeah, the camera knows it's a human, but does it know that that human just climbed a fence into your space?
Hmm.
Sometimes the edge can't handle that level, and so um, or learning new things if a situation changed and you're talking about a busy environment. If you have a busy environment, then a smarter system could know, okay, this time of day, it's usually really busy, but there shouldn't be any activity this time. And it can say, hey, I see a person here at this time of day, and there usually isn't a person hanging out here this time of day. So maybe that's an issue. They also have capabilities of taking multiple sensors and saying, hey, I saw a person and I got a door forced open. Hey, now this is something you really need to react to.
Hmm.
So there are ways that, and those sort of models, they don't usually take what the camera manufacturer provides as a something.
Hmm.
They're running their own algorithms from their own models that they've trained, because then now they're taking all different sensors from different sources, and they want to make sure that their model reacts the same on the data. Where if you take different camera manufacturers, their algorithms might detect differently. And so you can't take all of those different people's sources. So then if you're implementing those deeper inference sort of systems, then it doesn't really benefit you to have all of this computing power at the edge, because you already have to send them all your data anyway. So you're not getting the benefit of reduced bandwidth, right? So there are things, it depends on, benefits or limitations. It really depends on how you want to use that data. If you're all within the same environment, you have the same camera manufacturers, very specific things that you're looking for,
Hmm.
then edge AI can absolutely be your best bet, right? Because it's cheaper in the long run for you. If you're also implementing those other levels of AI systems,
Mhm.
then maybe you're better off with a dumber edge device
Mhm.
that's going to be cheaper in the beginning, and then spend your money on the bandwidth and the compute power and stuff to do those deeper level connections between different types of sensors.
Herein lies the benefit of working with a security consultant right now. Um, sorry, I had to give you a plug. But I want to go back to something you said with regards to manufacturers making it, and then what they make and then what they put out might not be effective enough in the real world, right? And have you heard of the term synthetic data?
No.
So it's been around actually for years, but I came across it recently as I'm in this whole AI game now. And what happens is if you make a machine learning model, you need a lot of examples to teach it, right? Before it comes off the shelf and it gets at cars and people. So, the manufacturers aren't slapping cameras on walls and just letting it sit there for 5 years while it collects like a million images of cars. What they're doing is they're feeding it synthetic data of here's what a car looks like, and then teaching it over time. It spits out a good detection of a vehicle. Yes, that's good, right? And it's learning and better and better. Once they get a high probability of success, hey, you're ready for prime time, ready for buy. And so when it goes out in the wild, to your point, is when they get, I guess, in the reverse, non-synthetic data that it learns from. And I think that's why in some systems, maybe, I don't know if you've seen this, that it also allows the end user to make the decision of what is not a car, what is a car, what is not a human, what is a human, to teach it in the non-synthetic environment or non-synthetic data environment. And so,
And I've seen that
yeah,
more, the teaching, I've seen that more when it's not all the way at the edge.
tell me more.
Well, like, when you have these other systems, more at the near edge, right? Or
Mhm.
NVR type level before it goes up, or computing, cloud computing, they tend to give you more capabilities of training your model.
Mhm.
What's like, no, that's actually an animal, or not, not a human, that kind of thing.
Mhm.
But I haven't seen a lot of cases where you can teach the edge cameras
Mhm.
what something is. And maybe that's coming, or it's out in certain areas. I haven't seen that much, but I do think that's an important thing to, really be able to interact, like you said, the end user teaching their model.
Yeah, and I'm sure that would come. I mean, they're already accessing tools where they can fine tune uh, bots for different tasks. It's just where those are running on. So, and that's a question of where the compute lives. I mean, I'm selfishly a fan of cloud and SaaS, but I also am realistic about where I think these things land in certain customer verticals. And so, I think of solutions like generative AI or more progressive solutions that will come out. Maybe it's interactive, or who knows, AGI or something else even greater than that. Is that I don't know. I fail to think that that's ever going to live for most customers, like on an on-prem server, or that they can afford it. The number of CPUs, GPUs, transform. I think the costs are going up, and I feel like a natural progression is some aggregation to cloud. Maybe I think you used a good example earlier. You said, I'm paraphrasing obviously, but like the ML on the edge is doing like the kind of lighter AI grabs at cars, people, animals, whatever. But then when it gets more complicated, like I need to know what type of car, then you have the on-prem server, maybe larger compute power that can make those decisions. Now, to your point, how I'm training models, how I'm having the model maybe do actions for me. So, meaning like, hey, there's a problem. I might have a model that just goes ahead and makes a decision for me in the cloud to say, hey, if you see these things, it's a false alarm. If you see these things, just go ahead and call the police. If these things, so it starts to fit in for that operator, the security operator, as opposed to it just telling them something's going on, right? So I'd love to get your thoughts on just on that topic in general, right? How does this stuff scale with the advancements of AI, right? So we know ML, okay, it's been around for years. There's really nothing super special about that on on the edge. What will be special is that how much more ML they could put on the edge based on the smaller chipsets and higher computing power, like you said, environmental considerations, whatever. That will be cool because that means cameras will just get smarter over time, and there's a lot of benefits there, as you mentioned. But I'm curious, like with the advancements of what we're seeing and how fast it's going, like where does more advanced versions of AI live when it comes to edge pros and cons?
I really think that a lot of the more advanced stuff is still at the near edge.
Mhm,
When you talk to a lot of the AI companies that are analyzing all your data, they usually want an on-prem server because they have so much more computing power,
mhm,
uh, on that on-prem server, and it would take way too much bandwidth to send everything up at the resolution that they need to really get the good data. And so, as we're advancing our networks, I think
mhm,
we're figuring out how to effectively compress data more, and we're improving our networks. And so I think as those things are improving, we'll be able to do more in the cloud. And like you said, it's super scalable. And so you use what you need when you need it, kind of thing, right? It can grow, expand, and contract based
mhm,
on your needs, where any servers on site don't have that same flexibility. And
mhm.
so I think it will go more towards the cloud. And I also agree that it'll be less of the near edge computing, more on the cloud, and more at the edge with better capabilities of the edge devices learning models connecting to the cloud and getting better data from that shared group mind kind of concept where you know this camera over here learned something new. It got trained by the owner that this is something, and then shared that data up to the cloud, and then the cloud shared it back down to all the other devices. And so now they all know this is the new thing, right? This is this type of creature or whatever they're trying to detect.
That's awesome. Yeah, that's really insightful. I've definitely learned, not that I haven't learned other podcasts, but I definitely learned some stuff here today. So this has been awesome. Yeah, I think that just the thought of like how things are moving so quickly and how this edge conversation is coming up so much that I hope that the audience is valuing this as much as I am. I think this is great. Thank you, Chris. So we're at that part of the segment where we would love to hear what you're working on, what you're excited about, right? What you're working on that you're excited about, rather, and also where people can find you.
So what I'm excited about right now, security industry has been changing rapidly, and because of that, really implementing all of these different systems and getting them optimized for our customers has been a challenge. Uh, and so our company has been focusing a lot more on the implementation support and the programming, and making sure systems are very consistent across the board. If you're dealing with a GSOC operator that has to deal with things in different parts of the world, everything looks and acts and is named, very consistently. It makes their job easier. So
Mhm.
we're doing a lot more of that implementation support, and I'm kind of excited about doing that, versus a whole lot of little projects, but really focusing in on getting more certifications with different manufacturers and getting more into the weeds of really getting to take advantage of all of these cool new tools that we have available, right? And making sure that the end result that the customer gets is actually what they were sold to begin with. And I think that that was an area that's kind of been challenged or missing, and so I'm excited that we're getting more involved in that realm. And then you said where to find me. Okay, so security by design. So sbd.us is our website, um, and my email is Chrissy _McCutcheon at sbd.us.